A lawyer submits a brilliantly written legal brief to a federal court complete with citations, precedents, and flawless formatting. The arguments are sound, the logic is persuasive, and the language is authoritative. There is only one problem. The cases cited in the document do not exist. They are complete fabrications, invented out of digital thin air by a generative AI program asked to assist with legal research. The machine did not set out to deceive. It simply did exactly what it was designed to do. It generated highly probable text. This is the reality of the AI hallucination. It is a critical challenge where large language models produce plausible-sounding but factually incorrect or entirely nonsensical information. When these systems easily invent facts, they do so with the exact same unyielding confidence they use when reciting the laws of thermodynamics or summarizing a historical event. The output is seamless, making the false information incredibly difficult to detect on a casual read. Understanding how AI models generate false information is no longer just an academic exercise for computer scientists. As these systems are integrated into search engines, medical diagnostics, financial forecasting, and daily workflows, explaining this phenomenon becomes a matter of public safety and societal trust. We are trusting our digital infrastructure to systems that can and do confidently hallucinate. To grasp why this happens, we must look under the hood of generative AI. Large language models do not possess a database of facts. They do not query a digital encyclopedia to find answers. Instead, they operate on the principle of next token prediction. During their training phase, these models ingest vast datasets representing billions upon billions of words from books, articles, websites, and forums. They map the statistical relationships between words, learning which terms are most likely to follow others in any given context. When you ask a model a question, it is not thinking about the meaning of your words. It is calculating probabilities. It looks at the sequence of words in your prompt and mathematically determines the most likely next word, or token, to follow. Then it predicts the next and the next, constructing a response one statistical guess at a time. It is a highly sophisticated, multi-dimensional version of the autocomplete feature on a smartphone. The brilliance of this architecture is also its primary vulnerability. Because the system is optimizing for linguistic fluency rather than factual accuracy, it prioritizes sounding correct over being correct. If the statistical weights in its neural network suggest that a certain fictitious legal case name flows perfectly within the context of a legal argument, the model will generate it. The system lacks an internal mechanism to verify its own output against objective reality. One of the root causes of these fabrications lies in the training data itself. The Internet is a messy, contradictory, and biased repository of human knowledge. When a model trains on this data, it absorbs the noise along with the signal. If there are gaps in the training data regarding a specific niche topic, the model does not inherently know to say that it lacks the information. Instead, its predictive engine attempts to fill the void with whatever statistically adjacent information it can find. This compulsion to answer is often baked into the system's fine-tuning. Developers want their models to be helpful and responsive. Consequently, the systems are heavily penalized during training for being evasive or failing to provide an answer. This creates a structural bias toward generation. When faced with a prompt about a subject it lacks sufficient data for, the model leans on patterns, stitching together fragments of related concepts to construct a highly plausible yet entirely false narrative. The architecture's design forces a relentless trade-off between creativity and factual reliability. In the industry, developers adjust a parameter often referred to as temperature. A higher temperature allows the model to select less probable tokens, resulting in more creative, varied, and human-like text. This is fantastic for writing poetry or brainstorming marketing copy, but turn the temperature up when asking for historical facts or medical dosages, and the risk of the model inventing details skyrockets. Even at lower temperatures, the illusion of comprehension persists. The models are so adept at mimicking human reasoning that users naturally project intelligence and understanding onto them. We assume that because the machine speaks like an expert, it must reason like an expert. This anthropomorphism blinds us to the reality that we are interacting with a statistical pattern matcher, making the eventual hallucinations all the more jarring and dangerous. The real-world impact of this disconnect is already manifesting across critical sectors. In healthcare, professionals experimenting with generative text for medical summaries have found models occasionally fabricating patient symptoms or inventing non-existent drug interactions. Because the medical terminology is deployed flawlessly, these errors require intense expert scrutiny to catch. A hallucinated fact in a clinical setting is not a mere glitch, it is a potential liability. Similarly, the spread of misinformation is supercharged by the confident fluency of these models. Malicious actors, or simply careless users, can prompt systems to generate detailed, authoritative-sounding articles supporting conspiracy theories or false political narratives. The model will obligingly invent quotes, cite fake studies, and construct logical frameworks to support the requested falsehood. The internet is slowly being flooded with synthetic text that looks factual but is fundamentally unmoored from reality. This creates an asymmetric warfare scenario for truth. It takes mere seconds for a language model to generate a 1,000-word essay filled with plausible fabrications. It takes a human expert hours, if not days, to meticulously fact-check and debunk those specific claims. As the volume of synthetic content increases, our traditional methods for verifying information are buckling under the weight of automated fluency. Recognizing this existential threat to their products, AI laboratories are racing to develop mitigation strategies. One of the primary battlegrounds is the fine-tuning phase, specifically through reinforcement learning from human feedback. Human evaluators review the model's outputs, penalizing hallucinations and rewarding factual adherence. This process helps align the model's behavior with human expectations, teaching it to express uncertainty or refuse to answer when it lacks information. However, human feedback alone cannot rewrite the fundamental nature of next-token prediction. To truly anchor these systems, engineers are implementing a technique known as retrieval-augmented generation. This approach fundamentally alters how the model interacts with a user's prompt. Instead of relying solely on its internal, pre-trained statistical weights to guess the answer, the system is given a new tool. When a query is received, a retrieval-augmented generation system first searches an external, verified database, like an internal corporate wiki, a medical database, or a live internet search, to find relevant facts. It retrieves this factual context and feeds it directly into the language model alongside the user's prompt. The model is then instructed to generate its answer based strictly on the provided documents. This shifts the model's role from a memorizer of facts to a synthesizer of provided information. By forcing the system to cite its sources from the retrieved data, developers can significantly reduce the rate of hallucination. If the model tries to invent a fact, the system can cross-reference the output against the retrieved documents and flag the discrepancy. It is a powerful method for injecting objective reality into a statistical engine. Yet, even retrieval-augmented generation is not a silver bullet. If the external database contains errors, the model will faithfully summarize those errors. Furthermore, models can still misinterpret the retrieved text, drawing incorrect inferences or hallucinating connections between disparate facts. The fundamental architecture remains probabilistic. The ghost in the machine is still guessing. It just has a better reference manual to guess from. This brings the AI community to a profound philosophical and technical crossroads. Is the tendency to hallucinate a bug that can be squashed with enough data, better algorithms, and tighter grounding? Or is it an inherent feature of generative AI? Many leading researchers argue that the very mechanism that allows these models to be creative, to translate languages, and to write code, which is their ability to connect distant concepts and generate novel sequences, is the exact same mechanism that causes them to invent facts. If hallucination is inextricably linked to creativity, then the quest for a perfectly factual generative model might be a paradox. The goal may not be the complete eradication of false information, but rather the development of highly reliable containment systems. Future architectures might involve an ensemble of models, utilizing a creative generator paired with a rigid, fact-checking discriminator that constantly audits the generator's output before it reaches the user. The commercial stakes for solving this are astronomical. Enterprises cannot deploy customer-facing chatbots that confidently invent return policies. Financial institutions cannot rely on analytical tools that hallucinate revenue figures. The transition of generative AI from a fascinating novelty to foundational enterprise infrastructure hinges entirely on solving the factual reliability problem. Trust is the currency of adoption. Consequently, we are witnessing a massive shift in how AI models are evaluated. The initial hype cycle focused on standard benchmarks, such as how well a model could pass a standardized test or write a basic script. Now the industry is pivoting toward rigorous adversarial testing specifically designed to induce hallucinations. Red teaming, where engineers intentionally try to break the model's factual guardrails, has become a critical phase of the development pipeline. For the public, navigating this landscape requires a fundamental shift in digital literacy. We must unlearn the instinct to trust the machine simply because it sounds authoritative. A beautifully formatted response is not a proxy for truth. Interacting with large language models requires an adversarial mindset, where every critical claim is treated as a hypothesis requiring independent verification rather than a settled fact. This cognitive burden on the user is significant. As AI becomes embedded in our word processors, email clients, and search bars, the friction of verifying information will increase. We are entering an era where the cost of generating text has plummeted to near zero, but the cost of verifying that text remains entirely human. The time saved by having an AI draft a report may be entirely consumed by the time required to ensure the report is not a sophisticated work of fiction. The phenomenon of the AI hallucination forces us to confront the limitations of our own technological creations. We have built machines that have mastered the syntax of human knowledge without grasping its semantics. They know how to speak, but they do not know what they are saying. The map of language they have drawn is incredibly detailed, but they have never visited the territory. Looking ahead, the evolution of these systems will likely bifurcate. We will see the development of highly constrained, domain-specific models designed for absolute precision in fields like law and medicine, where the temperature is set to zero and the grounding is absolute. Alongside them, massive, generalized models will continue to serve as creative engines, brainstorming partners, and coding assistants where a certain degree of hallucination is tolerated as the price of innovation. The ongoing struggle to align AI's impressive fluency with factual reliability will define the next decade of artificial intelligence research. It is a race between the scaling of parameters and the refinement of control mechanisms. Every breakthrough in model size brings new capabilities, but also new complex ways for the model to confidently deceive us. The engineering challenge is immense, requiring innovations in architecture that we are only just beginning to conceptualize. Ultimately, understanding how AI models generate false information empowers us to use them safely. It strips away the magic and reveals the mathematics. By recognizing these systems not as omniscient oracles, but as highly advanced statistical engines, we can harness their incredible power while mitigating their inherent risks. The future of AI is not just about building smarter models, it is about building wiser ways to interact with them.